Assalamu alaikum dear students. Today's topic is secondary growth in dicot stems. There are two regions in a dicot in which secondary growth occurs: stellar and extrastellar. And this is stellar and this is extrastellar. The growth which occurs in the stellar is called stellar growth, and the growth which occurs outside the stellar is called extrastellar growth. First of all, we will discuss stellar growth. Secondary growth occurs in case of dicot stems, roots, gymnosperm stem, and roots. It is absent in case of monocots because vascular cambium is absent. Vascular cambium is absent, that is, vascular bundles are closed. Now, first of all, it is stellar growth. Since we know that in case of dicots, the vascular bundles are conjoint, collateral, and open. Conjoint means xylem and phloem are located on different radii. Collateral means having one xylem and one phloem group, and open means in which there is presence of a cambia, vascular cambia. Now, the tissue which is responsible for secondary growth in case of dicot stems is vascular cambium. Vascular cambium. This vascular cambium present in the vascular bundles is called intravascular cambium. That means the vascular cambium present in the vascular bundles is called as intravascular cambium. This intravascular cambium is primary in origin and secondary in function because it is formed from procambium, and secondary in function because it forms secondary tissues like secondary xylem, secondary phloem, and secondary medullary rays. Cambium is made up of two types of cells: ray initials and fusiform initials. They form medullary rays and they form secondary xylem and secondary phloem. This vascular cambium is a lateral meristem because it is responsible for secondary growth or lateral growth. As the growth continues, the intervascular cambium, which is present in vascular bundles, also becomes active. So the alternative strips of intra and intervascular cambium constitutes a cambial ring. This cambial ring cuts cells on outer side as well as inner side. More cells are cut towards this inner side and less towards outer side. The cells which are cut towards this inner side, they constitute secondary xylem, and those cells which are cut towards outer side, they constitute secondary phloem. Then secondary medullary rays are formed from ray initials of this vascular cambium. Now this secondary xylem, in case of gymnosperms and dicots, it constitutes wood. So botanically wood is secondary xylem, not primary xylem, not primary phloem or secondary phloem. It is secondary xylem. The wood is of different types, like it is porous wood, it is non-porous wood, it is spring wood, it is autumn wood, it is hardwood, it is sapwood. Porous wood is that type of wood which is having vessels in its xylem. That means the wood which possesses vessels in its xylem constitutes porous wood. Porous wood is found in case of angiosperms. And non-porous wood is that type of wood which lacks vessels in its xylem. That means vessel-less wood constitutes non-porous wood. It is found in case of gymnosperms. Then there is spring wood and autumn wood. The wood which is formed earlier in a year, that means during the spring season, constitutes spring wood, and during leaf fall or autumn, it constitutes autumn wood. Then there is hardwood that is formed inside, and sapwood that is found outside. Spring wood plus autumn wood, it constitutes an annual ring or growth ring. So one annual ring is equal to spring wood plus autumn wood. Study of these growth rings helps us to determine the age of a tree. The study of this annual ring or growth rings is called as dendrochronology. For example, if there are 100 growth rings in a plant, then as per this dendrochronology, its age is 50 years because there are 2 rings formed in a year. Thank you. This was a brief account about secondary growth. You have